Erosion and deposition. Look at the topography of the land around your home and school. Perhaps you can see hills and valleys, or maybe there is a large rock formation nearby. Do you wonder how the landscape looked over 1,000 years ago? What about how it will look 1,000 years from now? Geologic features such as hills, canyons, rivers, lakes, and shorelines do not stay the same over time. These features change due to the interrelated forces of weathering, erosion, and deposition. Weathering is the breaking down of rocks through physical or chemical means. Erosion is the transportation of the products of weathering away from their original location. Deposition is the process by which the rock, soil, and sediment settle into their new locations. These processes occur due to the action of water, wind, glaciers, and gravity. Some processes take place quickly, while others occur gradually. Landscapes can change in just hours, days, or weeks due to the action of landslides, volcanic activity, or flooding. However, noticeable changes caused by glaciers or winds may take years, decades, or centuries to occur. Erosion by water. Streams and rivers can carry small particles from one location to another. The matter carried by moving water is called a suspended load. The size of the particles that can be carried by a stream or a river is determined by the speed of the water. Fast-moving streams can carry bigger and heavier loads than slower streams. As the speed of the water decreases, particles are deposited in order of size. The largest particles are deposited first, and the smallest, such as clay and silt, are deposited last. Over time, water erosion can cut deep valleys into canyons into Earth's surface. Under the surface, groundwater dissolves some types of rocks, such as limestone. This leaves behind caves and sinkholes. Water erosion caused by ocean waves wears away shorelines and changes coastal rocks. And you can see a picture here of the Grand Canyon, which was formed through the process of water erosion. Erosion by wind. Wind can transport particles over large distances. The wind's ability to transport particles depends on the wind speed, particle size, and how the particle is attached to the landscape. Because plant life and water content help particles stick to the Earth's surface, wind erosion occurs more readily in arid regions than in more humid areas. And here you can see that the Black Rapids Glacier was changed by rock slides. When a surface is repeatedly struck by particles carried in the wind, the surface becomes very smooth. This process is called abrasion. Abrasion can occur on natural surfaces such as rock formations or on artificial surfaces such as buildings. The geological structures that are formed due to wind erosion and deposition vary based on the type of particle that is transported. Depositions of sand particles are called sand dunes. Depositions of dusty silt and clay are called losses. Erosion by glaciers. Approximately 10% of Earth's surface is covered by glaciers. Moving glaciers erode the surface of the ground beneath them and deposit particles in new locations. Glaciers typically move only about a meter or 3 feet per day. Glacial erosion occurs on an extremely long time scale. When water from a glacier melts and seeps into cracks in the surface rocks, it can refreeze and push rocks away from their original location. This process is called plucking because the glacier is plucking the rocks from the ground. Plucking leaves behind a jagged appearance because rocks become embedded in the ice. Erosion by gravity. Gravity can cause loose particles to move downhill. This process is called mass movement. For mass movement to occur, the downward force of gravity must be greater than the upward force of friction. Landslides, mudslides, rock slides, debris flow, and lahars are examples of mass movements. These events can change Earth's surface quickly. They also frequently damage surrounding structures and can even result in the loss of life. Although mass movement cannot be completely avoided, human intervention can reduce the damage caused by mass movements.